Good morning. Welcome to physics class. Today we are going to the study about the accuracy, error, and also the significant figures. So, what is the meaning of the accuracy in the physics? So, let us consider the closeness of the measured value to the what here the true value of the physical quantity is called the accuracy of measurement. So, the measurement, each and every measurement is needs and what here the accuracy. If you consider a scale, if you want to measure a length of a line with the help of a scale, we need a what here the accurate measurement for that. So, you know the true value and also the measured value, what actually you are measured. The closeness of the measured value to the what here actual value, or we can call it as a true value of the physical quantity, is termed as an what here accuracy of the measurement. So, we have another word is called as precision. The precision means the extent or a limit to which the measurement of a physical quantity is done. So, the precision means the extent or a limit to which the measurement of a physical quantity is done is termed as an what here the precision. How much we are nearer to the what here the true value is termed as an what here the precision. Now, each and every the measurement is having the error. Error is due to what the human error may be. You are not keeping the device in a proper manner. So, what is the meaning of this error? A error is the measurement of physical quantity is defined as the difference between the what here the true value and the measured value. A true value is differ from the what here the measured value. Whenever this the difference is there, then we can call it as an what here the error. If a true value is equal to the measured value, means there is a no error. So, there are several types of error is there. One is called as a systematic error, another one is called a random error. A systematic error is the one which is according to the definite pattern it will comes. So, always it is the same thing, same kind of error which has come. So, that is termed as an what here the systematic error. The error which occurs according to the what here definite pattern is termed as an what here the systematic error. This particular systematic error is obtained due to what here the instrumental error, the personal error, or we can call it as another one is called a natural error. So, you see the instrumental error, each and every instrument is not a perfect. Okay, there is some errors which is present. So, maybe you are using a vernier caliper, a screw gauge, or a physical balance. So, you will get some kind of error here. These are all instruments. The error caused due to the faulty design of a what here or a calibration. The calibration is not proper. The mentioning the numeric on the what here instrument is not proper, and there is a fault in the what here the design itself. Then it is termed as an what here the instrumental error. Next one is called as a personal error, the error in which the measurement of physical quantity is due to what a limitation or carelessness of an observer. We will not observe properly. For example, in a simple pendulum experiment, you are not counting the proper oscillations. If you not count the proper oscillations, then it is termed as an what here the personal error. while using a scale, or we can't able to find out what here the zero error of that instrument. So these are all termed as an what here the personal error. So the mistake or error is done by an observer is known as a what here the personal error. And the last of its kind is called as a natural error, the error arising due to the change in the condition or environment. Maybe the temperature changes, the pressure is changes, depends on the what here, the temperature goes on changes. Due to that, there is a change which is occurs, the error which comes to the instrument itself. So this is the natural error. The error arises due to the change in the what here, the condition of environment, are known as what here, the natural error. So we have another type is called as a random error. The error whose cause, what is the reason for that, are not known precisely and which cannot be removed are termed as an what here the random error. It is not due to the instrumental error, the personal error is not there, even the natural error is also not there, but there is an error which occurs. The error whose cause are not known, then it is termed as an what here the random error. How to minimize this particular error? Okay, error can be expressed in different ways. That is called as an absolute error, mean absolute error, relative error, and the last one is called as a percentage error. So what is an absolute error here? The absolute error of a given value of a physical quantity is the difference between the observed value and also the mean value of the physical quantity. So let us consider the x is nothing but what here the mean value of a measured quantity, and xi the value of the quantity the measured in a ith observation. So there are number of observations are there. If you use the vernier caliper, if you use a screw gauge, there are a number of observations which is present over there. So that is an ith observation. The first observation, second observation, third observation, that is nothing but in what here I. It is mentioned as what here ith observation. So that is mentioned as a delta xi observation is equal to ith observation minus of x. So this is termed as in what here absolute error. Mean absolute error means take this one the delta x1, delta x2, delta x3, delta x4 up to what here the delta xn. So this is nothing but an arithmetic mean. So number of observation means I had done the particular experiment for 5 times, for 6 times, only 3 times. Divide that by the 3 or 4 or nth times, then you will get a what here mean absolute error. It means that the arithmetic mean of the what here the magnitude of absolute error. Magnitude means even the minus value is there, you have to consider it as what here plus, that is a positive value of anything is termed as an what here the magnitude. Then what is the meaning of relative error? The mean absolute error to the what here the true value of that is termed as the relative error, and the relative error into 100 means you will get a what here the percentage error. Okay. So if you let us consider the one simple example to find out what here all of these the 4 things, that is absolute error, mean absolute error, relative error, and also what is that the percentage error. We have one simple example is here. Okay. The value of diameter of a wire are measured as what here 2.04 at the first time, second time it is 2.06 millimeter, 2.08 millimeter and 2.07 millimeter and 2.05 millimeter, etc. like this. So, here we need to find out what first one is what here average diameter of this, and then first one is what absolute error, mean absolute error, relative error and also percentage error. All these the four things we need to what here the find out: absolute, mean absolute, relative error and also the percentage error. Okay, all these four things. Okay, if you do one problem, then you can understand the entire all 4 points. Let us do this thing. Okay, the value of the diameter of the wire is measured by using a what a screw gauge. Okay, diameter is always measured with the help of what here the screw gauge. One time it is gets 2.04 millimeter, 2.06 millimeter, 2.08 millimeter and also 2.07 millimeter and 2.05 millimeter. How to find out the average of this? Mean value you can take it. Okay, add all the things. Okay, 2.04, 2.06, 2.08 and add all these things. How many times you have done? 5 times you done. So, that is equal to 2.0. This is an average diameter of it. What is an absolute error? Absolute error is nothing but what here delta x1 to the what here. So, this the average diameter of this. Please see this the formula here. Okay, this is the delta x1 is an xi, the value of the quantity measured in the ith observation minus of x. So, therefore, what you will get is here delta x1, delta x2, I just mentioned as d1, d2, d3, d4, d5 like that. Okay, you just see this one 2.06 minus of 2.04, that is the first value of this 2.06, 2. Every value is minus by what here 2.06. So, what you will get 0.02, 0.000. So, there is a no error in the second one. So, that is delta x2. In delta x3 there is an error, minus error you will get 0.02. This is an absolute error. These are all considered as an absolute error. First one, second one, third one, fourth one and also fifth one. Understood? Now, we have a mean absolute error. Take this one as a delta x1. So, I mentioned as delta d1 here. So, just take it as x1, delta x2 plus delta x3, etc. like that. So, magnitude of that, even though you will get a minus value is here, consider this one as what here? The plus value of this. Okay, this is always positive. The magnitude means what here? The positive value of anything. Okay, then divide by the nth time. Nth time means the 5 times we had a 1, 2, 3, 4, 5. So, there is 5 times. So, you will get a 0.02 millimeter, that is called mean absolute error. In the same manner, do the relative error. Relative error means 0 delta d or x. This one is x. So, 0.012 millimeter divided by what is that? 2.06. Here it is there, the average value of this. So, you will get 0.058. And then how to find out the percentage error? Just multiply with the 100. So, you will get a what here? Just multiply with the what here? 100. So, you will get a 0.08%. So, this is how you can able to find out, okay, all absolute error, mean absolute error, relative and also the percentage error. So, please try this problem. Okay. And then let us pass on to the what here, the next significant figures. So, what is the meaning there by a significant figures? The significant figures are those digits in a number that are known with the certainty plus or more digit that is uncertain. Some of the digits are uncertain, some of the digits are certain. Certainty plus one more digit that is uncertain. Okay. So, to find the significant the figures, how to find out this this significant the figures. Rules to find out the significant figure. All non-zero digits are significant figures. So let us consider the 16. There is no zeros or present. How many significant figures have? 2 significant. Here is 1, 6, 8, 2, 5. There are the 5 significant values are there. Secondly, the all 0 occurring between the non-zero digits are significant figures. 1, 0, 0, 5, they are having 4 significant figures. In the same manner, all zeros to the right of the last non-zero digits are not significant. 6, 3, 4, here is the 0, do not consider this as a significant figure. 6, 3, 4 only the significant figure. So, there are 3 significant figures. In digit less than 1, less than means 0.123, like that we will get. Okay. So, in these digits, the right of the decimal point and to the left of non-zero digits are not significant figures. So, for examples, you have 0.00234, only here is a 234 is considered as what here 3 significant figure. All zeros to the right of a non-zero digit in the decimal part are significant. So, let us consider here 1.36540. So, just consider 13654. So, up to here there are significant figures, there are 5 significant figures out there. So, with the help of this we can round off, okay. Rounding off in the measurement or the very important the requirement in physics. So, what is the meaning there by rounding off? If you take so 6 rupees 99 paise, okay, it means that we will round off to what here? The 7 rupees. So, in the same manner, what is the rounding of this measurement? If the digits to be the dropped is less than 5, then the preceding digit is the left unchanged. For example, 1.64. So, here is the 4 is there. So, you can round off to what here? 1.6. So, in the same manner, let us consider if the digit is dropped to the greater than 5, 2.49 is there, 9 is last digit here after the decimal place. We can round off to what here? 2.5. In the same manner, if the digit is dropped is 5 followed by the digit other than 0, then the preceding digit is raised by 1, 2.55. So, it is round off to what here? The last digit is 5 here. So, that is why it is 2.6 it will becomes. If the digit is dropped is 5 or 5 followed by the zeros, 5 is followed by the 0, it is remains as what here? Here is a 5 is there here, the last there is a 5, okay. Then it is round off to what here? 2.8, and 4.670 is round off to what here? 4.6. So, this is what the significant figures and how this is how we can rounding off the measurements, okay. So, thank you for watching the videos. Thank you very much.